properties of it. Of course, it has the springs we expect from them a few more benefits. As for example, we expect from them to increase the robustness of the system because of, if you look at the spring, it can act as a low-pass filter against peak torques, which allows us to apply very high impacts to the system, as we will demonstrate in the second in the video, where we try to get very much energy into the system, and the springs will basically buffer the energy and prevent it from destroying the gearboxes or the motors, as you see. Excuse us that we don't do the demo live now here, but we don't have a baseball bat. The springs can be used in an additional way. What a spring is basically, it gives you a correlation between a displacement and a force. Thereby, by just measuring the displacement of the spring, you can measure the force acting on it. And as we have like springs in each of the joints, if we apply a force to the robot, the spring will result in the displacement, and we can measure the joint torques which we apply. Therefore, we can use in such a system a lot of the methods which have been developed in the last few decades for torque-controlled robots, as I do it. For example, now I just put it in zero torque mode with gravity compensation, and I can easily move it around. And although the robot itself weighs 13 kilos, it just acts as it would be in outer space. Yeah. What we demonstrated in this drawing demo was that what we tried to implement here are basically perfect springs, which means when we put energy into the springs, we want to get as much as energy out of them again, because of this means that we can basically design highly performant tasks. But it also, of course, also has a downside, as now I put the system in the position control, and if I just exaggerate it, it oscillates very easily in a very complicated manner, as you look at, for example, at this motion here. And in most of the applications we do, and I don't know, service robotics, I guess this very oscillatory and shaky behavior is not desired, right? I mean, if I grasp a glass, I don't want to shake around like this because I will not be able to drink something. So what we now need to do is we have to suppress this oscillation. But actually, we didn't have enough space to put mechanical dampers into the system. So what we have to use, or what we wanted to use, are the electric motors and controllers, which are running in real time on the machines down there, right? So what we developed for this is a damping control approach. And if I switch to damping control, the system will not shake at all again. Of course, I can deflect it because of it has the mechanical springs, and we want to have these properties of the mechanical spring, but it will not oscillate anymore like crazy around. Okay, so far I think you saw